Here I am continuing with the previous video and will discuss some numerical examples here. The first example comes, which is compute a 4-point DFT of sequence x of n is equal to 1, 2, 1, 0. So I will read out the problem statements once again. Compute 4-point DFT of the sequence x of n is equal to 1, 2, 1, 0. So when the problem statement is given, you have to read out the sequence x of n and write down the capital N, and this capital N is the number of the samples or elements present in the sequence x of n. So how many number of samples are there in this sequence? 4, right? 1, 2, 1, 0. So there are 4 samples, n is equal to 4. So at the same time, you have to write down both n and k, and both these n and k varies from 0 to n minus 1. Therefore, it is 0 to 3 and 0 to 3 for both n as well as k, right? So once you write down capital N as well as small n and k, you have to find out how many number of twiddle factor values we want to compute the 4-point DFT. Since it is 4-point DFT, we need the 4 twiddle factor values starting from W0 to W3 with subscript 4, which is the length of the input sequence, that is 4. So how to calculate these 4 different twiddle factor values? We know the basic definition, that is Wn is equal to W4, because n is equal to 4, e raised to minus j 2 pi, n value is 4, so 2 ones are 2, 2 4s are 2s are 2, so which is e raised to minus j pi by 2. This is nothing but cos pi by 2 minus sin pi by 2 minus j sin pi by 2. Cos pi by 2 is 0, minus j into sin pi by 2 is 1, so minus j into 1 is minus j. Now calculate W4 is equal to minus j, W4 raised to 0 is minus j raised to 0, so anything raised to 0 is 1. Then W4 raised to 1 is minus j raised to 1 is minus j. W4 to minus j raised to 2 is equal to minus 1, because minus j into minus j is minus 1. W4 raised to 3 is minus j raised to 3, right, which is equal to 1, or else this is not 1, this is j. So I will make a change here, this is j, so this is j, right? So once you calculate all these 4 twiddle factor values, write down the DFT equation. So the DFT equation is x of k is equal to summation minus n is equal to 0 to n minus 1 x of n w raised to minus k, right? So x of k is equal to summation n is equal to 0 to n minus 1. So n minus 1 is what? 3 here. So it is 3. X of n I will keep as it is, and here it is W4 raised to k n. Sorry, this is plus k, not minus k n, right? So now we'll substitute these summation values. The varies from index value, n index value varies from 0 to 3. So we'll substitute that. So n is equal to 0 means it is x of 0, W4, and here it is n is equal to 0. So 0 into k is 0 plus. Next I will substitute n is equal to 1. So x of 1 into W4 raised to n into n is 1. So 1 into k is k plus. Next n is equal to 2 means x of 2 W4, and here n is equal to 2 into k is, I will write here 2k plus x of 3, for n is equal to 3 it is W4 raised to 3k. So that is equal to what? X of k, right? So I will write down this equation in the next slide. So which is I will write down, that is x of k is equal to, for n is equal to 0, this is x of 0 w4 raised to 0, plus for n is equal to 1, this is x of n w4 raised to 1 into k is wk, plus x of 2, for n is equal to 2, it is w4 2 into k is 2k, plus x of 3 multiplied by w4 raised to 3k, right? So let me consider this one as equation number 2, right? And from this equation x of k, which is expressed in terms of the sample values of input sequence, which are x of 0, x of 1, x of 2, x of 3. These are the sample values of the input sequence x of n, and these are the Twiddle factor values which we have already calculated. We know the values for these Twiddle factor values, right? So when x of n is given, which consists of 4 values 1, 2, 1, 0. So here it is x of 0 is equal to 1, x of 1 is equal to 2, x of 2 is equal to 1, and x of 3 is equal to what? 0, right? And for these sample values, we need to calculate the DFT values. So what are the DFT values? 4-point DFT values. You will get capital X of 0, capital X of 1, capital X of 2, capital X of 3. So these values you have to calculate. How to calculate the first sample of the DFT sequence X of 0? Just substitute k is equal to 0, right? So by substituting k is equal to 0, you will get capital X of 0, right? So in this you substitute k is equal to 0. So in the first term, so this is independent of k, we don't have any k term, so it is x of 0 and w4 raised to 0, plus x of 1 w4, and here it is k, so what is the value of k here? K is equal to 0, plus x of 2 w4 raised to k is 0, so 2 into 0 is again 0, plus x of 3 and w4 raised to 3 into 0 is again 0, right? So let us simplify. What is x of 0? X of 0 is 1 here. So 1 into w4 raised to 0 is what? W4 raised to 0 is 1, which I already calculated. W4 raised to 0 is equal to 1. So it is 1, plus x of 1 value is how much? It is 2. So 2 into w4 raised to is again 1, plus x of 2 value is 1, and what is w4? It is 1, plus x of 3 is 0, 0 into w4 raised to is what? 1. So what is the value? 1 into 1 plus 2 plus 1 plus 0, so which is equal to what? 4. So the first sample in the DFT sequence x of k is what? 4. Similarly, we can calculate x of 1 by substituting k is equal to 1, right? So again in this equation number 2, let us substitute. So the first term is independent of k, so it is as it is, w4 raised to 0, plus x of 1 into w4 raised to k is equal to 1 now here, so this becomes 1, plus x of 2 w4 raised to, and here it is k is 1, so 2 into 1 is 2, plus x of 3 into w4 raised to k is equal to 1, so 3 into 1 is 3, right? So now let us simplify this further. X of 0 is 1 into w4 raised to 0 is 1, plus x of 1 is how much? 2 into w4 raised to 1 is what? How much it is? Minus j, right? So it is minus j, plus x of 2 is 1 into w4 raised to 2 is how much? Minus 1, plus x of 3 is how much? 0, w4 raised to 3 is how much? It is plus j. So 1 minus 2j minus 1 plus 0. So this minus 1 plus 1 get cancelled. So what is the value? It is minus 2j. that is equal to x of 1, x of 1. So similarly we will calculate the next values, sample values in the DFT sequence, that is x of 2. How to calculate x of 2? We have to substitute k is equal to 2 in the expression 2, right? So what is the expression, right? The expression is, I will rewrite the expression here just for ease of convenience. So x of k is equal to x of 0 w4 raised to 0 plus x of 1 w4 raised to k plus x of 2 w4 raised to 2k plus x of 3 w4 raised to 3k, right? So now let us substitute k is equal to 2 here, so that you will get x of 2 is equal to x of 0 w4 raised to 0, since we don't have k term in the here. Next x of 1 w4, k is equal to how much? 2. No, this is w4 is to 2 plus x of 2 w4 is to 2 into 2 is 4 plus x of 3 plus w4 is to 3 into 2 is 6, right? But x of 0, x of 1, x of 2, x of 3 we know all are available in the given input sequence, but we have 4 twiddle factor values which are w0 to w3, but if you see here it is w4 is to 4 and w4 is to 6, right? Then these which are greater than 3, these can be replaced by the twiddle factors which we have calculated, right? So we have w4 is to 0 to what? w4 is to 3, but we don't have the values for w raised to 4 and w raised to 6. How to calculate these values? W4 and W6 can be calculated using the property of periodicity, right? Periodicity. Therefore, this W4 is to 4 is nothing but W4 is to 0. How? You can see here. By using this one, you can understand. So this is W4 is to 0. This is W4 is to 1. This is W4 is to 2. This is W4 is to 3, right? So this is 0, 1, 2, 3, 4. So again 4, W4 is to 4 is nothing but W4 is to 0 only. 4, this is 5. So W4 is to 5 is equal to W raised to 1. W4 is to 6 is equal to W raised to 2. 6, 7 is equal to 3. 8 means again W4 is to 8 means again it is 0. 9 means 1. So this is the one method to replace these values with available twiddle factors values. And one more method is there which is much simpler than this one and easy to remember also, right? So you should know, if you know the length of the sequence n is equal to 4, right? So whenever this value is greater than 3, because k is 0 to 3, right? K is 0 to 3 and n is 0 to 3, right? So whenever these values are greater than 3, just subtract the n values 4 from this value. So 4 minus 4 is how much? 0. So this you can replace it by what? W4 is to 0 and this is x of 2, right? Plus x of 3 and here it is W4 is to 6. Either you can use this method or whenever it is greater than 3, right, you subtract by 4. So 6 minus 4 is how much? 2, and I will keep these terms as it is, x of n W4 is to 2 and plus x of 0 W4 is to 0. So now substitute x of 0 is 1 into W4 is to is also 1 plus x of 1 is 2. What is W4 is to 2? How much it is? How much it is? Minus 1, right? Minus 1 plus x of 2 is 1 into W4 is to 0 is 1 plus x of 3 is 0, W4 is to 2 is how much? It is minus 1. So 1, this is minus 2, this is plus 1, this is 0, right? So 2 minus 2 is equal to how much? 0. What you will get? X of 2 is equal to what? 0. x of 2 is equal to 0. So similarly you can calculate for k is equal to 3. So you will get the last sample in the DFT sequence x of k, that is x of 3 is equal to, again write down, substitute x of 0 w4 is to 0 plus x of 1 w4 is to, how much it is, w4 is to 3 plus x of 2 w4 is to 2 into 3 is 6 plus x of 3 into w4 is to 3 into 3 is 9, right? 2 into 3 is 6 and here 3 into 3 is 9. Again x of 0 w4 is to 0 plus x of 1, right? w4 is to 3, till now is there is no problem. Now here x of 2 w4 is to, it is 6, right? The simple method is what? 6 minus capital N. Capital N is 4, so 6 minus 4 is 2 plus x of 3 w4 is to CA. 9 minus 4. So what is 9 minus 4? 9 minus 4 is 5, but this 5 is again greater than what? 3. So again you subtract it by 4. 5 minus 4 is 1. So I can write it 1. Alright. So x of 0 is how much? X of 0 is 1 into w4 is to 0 is 1 plus x of 1 is 2, w4 is to 3 is, again it is 1 plus x of 2 is 1, w4 is to 2 is, it is minus 1 plus x of 3 is 0 and here it is minus 3. So what we will get? 1 plus 2 minus 1 plus 0. So how much it is? 2. So x of, how much it is? So w4 is 2, 3 is not 1, so it is j. So this becomes what? J plus 1 minus 1 get cancelled, so it is 2j. So x of 3 is equal to 2j. So this is the required DFT sequence. Together you write x of k is equal to, x of k is equal to, first value is what? What is the first value? X of 0, 4. Next what is x of 1? The x of 1 is equal to, how much it is? Minus 2j. Next x of 2 is equal to 0 and x of 3 is equal to plus 2j. So this is the required, the 4-point DFT sequence, since there are 4 values in the DFT sequence.